Welcome to Cookies Maths and Science Hub. Today we'll be looking at the physics concepts of speed and velocity. Let's have a quick refresher on what scalar and vector measurements are. Remember, scalar measurements only have magnitude, or in other words, they only have the number, whereas vector measurements have both the number, or the magnitude, and a direction associated with them. Examples of scalar measurements are time, temperature, speed, distance, mass, energy, and power, while examples of vector measurements are velocity, acceleration, force, displacement, and weight. So, what is speed? What do we mean when we say the speed of an object? Speed is a measure of the distance traveled over a set period of time. In other words, speed is equal to distance divided by time, or distance over time. It is a scalar measurement, as we mentioned just before, meaning it does only have magnitude, it doesn't need direction, and it is represented by meters per second, or meters/seconds. You can also often see it written as ms to the negative 1. This is just another way of symbolizing meters per second. Velocity, on the other hand, is a measure of the displacement traveled over a set period of time. So in other words, velocity is equal to displacement over time. We represent displacement with an S and time with a T. So you'll often see it written as V is equal to S over T, or velocity is equal to displacement divided by time. It is a vector measurement, often easily remembered. They both start with V, so you can remember that this velocity is a vector, whereas speed is a scalar because it starts with an S. However, it is also measured by meters per second, so meters/seconds, or meters per second, or ms to the negative 1 again in some cases. Because it is a vector, in this case we need to make sure any velocity measurement is given with its direction as well. Before we go any further, let's just clarify the difference between distance and displacement, as they are quite similar terms, and it's really important to know the difference before we talk about the difference between speed and velocity. So, the distance of an object is how far it travels. Say you're going on a running race, as is imaged in this diagram here. You run around and go around all these different obstacles from the starting line to get to your finishing point. Displacement, on the other hand, is how far an object is from its starting point. So there on the map you can see, we're not that far from our starting point, but we have a great distance. Our velocity is measured on this displacement, how far you are from your initial point to your final point, where your speed is measured based on your distance, how far you have traveled in total. This is important to remember when completing calculations for both these values. An important thing to note is the difference between average and instantaneous speeds and velocities. Average speed or velocity is measured over a period of time, whereas instantaneous is the speed or velocity at a specific point in time. Let's look at a runner running 100 meters. If we were to record how long it took them, we would have their distance and their time. So we could calculate their average speed, because speed is equal to distance over time. However, if we had a speed camera, or something that the police might use to make sure you're doing the speed limit on the road, and we detected their speed at a certain point on their race, we would get their instantaneous speed. Think about it this way. If you were running 100 meters, you might run really fast for that first 10 meters, but then slow down for the rest. Your overall speed, or your average speed, will be indicative of how long it took you to do the whole thing, whereas your instantaneous speed in those first 10 meters will be different to your instantaneous speed in the last 90. As such, an average speed or velocity does not always determine the instantaneous. Okay, let's look at some example questions now. An object moves 18 meters north over 10 seconds. It then moves 6 meters south over another 2 seconds. What is its velocity and speed? Let's start with speed. So we know speed is equal to distance over time. Now let's make sure we double check what our distance is in this problem. So we've gone 18 meters north, then 6 meters south. So in total, our distance is 24 meters. And we've done so over a total of 12 seconds, just adding both times up there. So we're going to have 24 meters divided by 12 seconds, which is going to give us 2 meters per second. As it is scalar, we do not need to provide a direction. Our velocity, on the other hand, is equal to our displacement divided by our time. Now, from where we started, we went 18 meters north, but then came 6 meters back south, meaning we need to be careful we're only 12 meters from our initial point, because we went 18 meters one way, then 6 meters back. So 18 subtract 6 gives us 12. Our time in this example will be the same, as it has still occurred over 12 seconds. So then we'll have 12 meters divided by 12 seconds, which gives us 1 meter per second north. We need to make sure to include the direction there, as velocity is a vector measurement. Okay, let's look at a slightly more difficult one now that'll involve a few more steps, more so for that velocity side. As you can see, those ones often require a bit more thinking. An object moves 4 meters north, then 3 meters east over 10 seconds. What is its final speed and velocity? Okay, once more, speed is equal to distance divided by time, which means we'll have 7 meters, adding both our numbers together. So it went 4 meters one way, then 3 meters another, in total 7 meters, divided by our time, 10 seconds in this case, gives us 0.7 meters per second. Velocity, on the other hand, is equal to displacement divided by time. Now, in this example, we can't simply add or subtract them because they are not going in the same motion or direction, horizontally or vertically. If you need to practice a bit of vector addition, I suggest checking out our vector and scalar video. However, in most of these cases, in these problems that are a bit more simple, you'll end up just using Pythagoras. As you can see here in the triangle, it goes 4 meters north, then 3 meters south. So our displacement is going to be the hypotenuse of this triangle, or that longest side there. Using Pythagoras' rule, or theorem, we have A is equal to the square root of 3 squared plus 4 squared, so our A is going to be equal to 5. So we know we'll have 0.5 meters per second, because we'll have 5 meters divided by 10 seconds. However, we must also find the direction. Now, the direction is not as simple as saying north then east. We have to find the angle within the triangle. Using our trigonometric ratios, we can do this. Again, make sure you refresh yourself on these using our video if you're a bit unsure. But we'd have theta is equal to tan to the negative 1 of our opposite over our adjacent, in this case 3 over 4. And then our theta, or our angle, is going to be 76.39 degrees. So our final velocity will be 0.5 meters per second at north 76.39 degrees east, because we've gone from that north axis 76.39 degrees towards our east axis. As I said, these ones are a little bit more complex, and you won't encounter too many of these in your basic grade 10 physics, but it is good to practice them if you're extending yourself and looking at going into physics in the higher grades. Thanks for watching. Hopefully now you have a good idea of the concepts of speed and velocity, as well as distance and displacement. Be sure to give this video a like, share, and subscribe for future content related to physics, chemistry, and mathematics. Hope to see you again soon.